Why is it that astronomers will sometimes tell you that our universe is immeasurable by modern mathematics? Can our human brains even comprehend such abstract phenomena? Well, we can answer these questions by understanding the different dimensions of our universe. Now let's take a coin for example. Now this coin is no ordinary coin. Let us say that hypothetically it has no length, width, or height. It exists in zero-dimensional space and can be only characterized by time. It is theorized that this point was how the universe appeared before the Big Bang occurred, suggesting that it has an infinite density. Now, let's draw a number line, one of the basic figures of mathematics. We have entered the first dimension. Now imagine that you are an infinitely flat creature which only has length. You can move forwards and backwards, but all you would ever see is a single unchanging point. The vision of a one-dimensional creature is limited to a zero-dimensional view. The second dimension is a bit easier to understand. In algebra, we learn about the Cartesian coordinate system, which characterizes a point by an x and y axis. Now let's take Barry, for example. He is an infinitely flat creature who only has length and width. He can move forwards, backwards, up, and down. But what does he see? His friends Gary, Jerry, and Larry are all just lines to him. His view is limited to the first dimension. Now, let us understand our own universe, the third dimension. We can say an object in 3D has length, width, and height. Using the letters x, y, and z, we can locate a point's position in space. However, a third-dimensional creature can only see in the second dimension. Now, at first, this makes no sense. However, as the hypothetical creatures we discussed earlier only can view dimensions below them, our field of view is limited to a dimension below us. This is why you can draw a 3D cube on a 2D piece of paper and record 3D objects and view them on a 2D screen. The different hues of light and differences in perspective cause our brains to take a 2D image and view it as 3D. Now, to understand the fourth dimension, we must first comprehend how the dimensions interact with one another. When two 1D lines intersect each other, they do so at a 0D point. When two 2D planes intersect, they do so at a 1D line. When two 3D objects intersect each other, they do so at a 2D plane. So therefore, our 3D world must be an intersection of two 4D shapes. Now, how can we see in the fourth dimension within our 3D world? Well, we can do so through analogy. So this is a 2D net of a cube, and when folded together, it becomes a 3D cube. By altering the second dimension in the third dimension, we create a 3D shape. Now, using the same principle, we can create a 4D shape. This is what the net of a 4D cube looks like. Now let's fold it together. We create a tesseract, a 4D cube. Now to explain it, we must look at the 3D cube. As you see within the 3D cube, it seems as if the inner square is smaller than the outer square. But we know that in reality, all the sides are the same size. It is just a matter of perspective. Likewise, in a 4D cube, the inner cube is actually the same size as the outer cube. The transfer between dimensions distorts the size. This is what the 4D cube theoretically looks like. It's mind-boggling, isn't it? Now you may ask, what is the use of knowing dimensions? Well, they just allow us to create number lines, mathematical graphs, technologies such as virtual reality, and theories such as the Big Bang and string theory. They allow us to understand why humans thought the world was flat, and the secrets of the Mobius loop. They allow us to teleport. Yes, teleport. Remember Barry, the infinitely flat square? Well, his sister Mary has been captured by Larry and Perry. They placed her in an impenetrable square. How will Barry save Mary? Well, he can travel into the third dimension from the second dimension and back into the second by traveling on the z-axis. It seems as if he has superpowers to Larry and Perry. In the same way, if humans wanted to travel immense distances in a short amount of time, they could hypothetically enter the fourth dimension and return to be in another universe. A four-dimensional being would be a god compared to a 3D human. So I would like to end on one last note. You, a three-dimensional human being, have just watched on a two-dimensional surface a video of a three-dimensional person explaining on a two-dimensional surface what a four-dimensional object looks like in our three-dimensional world. So, congratulations on making it through the video. You have just grasped one of the most abstract concepts ever made.